Those colorful, trembling desserts look simple, but producing millions of identical portions begins with a surprisingly complex process. Before it becomes a colorful dessert, gelatin begins with collagen extracted, purified, dried, and transformed into a carefully controlled ingredient. Gelatin is a protein derived from collagen, and when hydrated and cooled, its molecular network creates the familiar soft, elastic gel. A typical flavored gelatin formulation combines gelatin with water, sweetener, acidulants, flavoring, color, and carefully controlled processing conditions. Industrial gelatin commonly comes from collagen-rich materials such as cattle hides, pork skins, or selected bones and connective tissues. Every incoming batch is inspected for identity, condition, temperature, cleanliness, and traceability before processing begins. The key is collagen structure. Controlled heat and pretreatment break its organized protein network into soluble gelatin molecules. Depending on the source and processing schedule, raw materials are transported under controlled conditions and transferred quickly into receiving storage. Inside storage, batches are identified and tracked so production can maintain consistent material history from receiving through final gelatin. Processing begins with washing, removing residual dirt and unwanted material before chemical pretreatment can work efficiently. Depending on the raw material, acidic or alkaline pretreatment loosens collagen structures and removes unwanted components before extraction. The conditioned material is held under controlled time, temperature, and chemical conditions until its collagen is ready for efficient extraction. Now the prepared collagen enters hot water extraction, where controlled heat gradually converts the collagen structure into soluble gelatin. Extraction can occur in successive stages, with different conditions used to recover gelatin efficiently while maintaining the desired functional properties. Before concentration, the gelatin liquor passes through filtration equipment that removes remaining suspended particles and protects downstream equipment. The filtered gelatin solution still contains a great deal of water, so evaporation concentrates the protein solution before it is dried. Controlled heat treatment helps manage microbial risk while process monitoring keeps the gelatin within its required temperature and quality range. After purification and concentration, the gelatin solution is cooled and formed into a manageable solid structure for drying. The formed gelatin then enters controlled drying, where moisture is gradually reduced until the material reaches a stable condition for milling and storage. Once dried, the gelatin is milled and screened so its particle size remains consistent during later mixing and dissolution. Now the process changes direction. Measured gelatin powder is combined with sweeteners and other ingredients to create the final flavored formulation. Flavoring and color are added in carefully measured quantities, giving each batch its recognizable taste, aroma, and appearance. Powerful mixing distributes the gelatin, sweetener, acids, flavors, and colors evenly so every portion can deliver the same texture and taste. Controlled heating helps dissolve the formulation and maintain the right flow characteristics without overheating the gelatin mixture. Before filling, the warm mixture may be de-aerated under controlled vacuum, removing trapped bubbles that could affect appearance and consistency. Now the prepared gelatin mixture reaches the filling line, where synchronized nozzles dispense carefully measured portions into thousands of containers. Immediately after filling, the containers are sealed with food-grade lids, protecting the product while automated systems verify that each seal is correctly positioned. Automation handles speed, but trained operators still matter, checking color, fill level, seal appearance, and unusual changes the sensors might flag. If viscosity, color, temperature, or filling behavior begins drifting, an experienced operator can pause, investigate the cause, and make controlled process adjustments. Image prompt. In the laboratory, samples are tested for properties such as gel strength, texture, moisture, and other specifications required for consistent production. On the production line, automated systems check portion weight, container position, seal integrity, coding, and visible defects at production speed. A failed unit is not simply sent back into production. It is identified, isolated, investigated, and handled according to the factory's quality and food safety procedures. Cleaning and processing generate wastewater containing organic material, detergents, and suspended solids, so the factory must treat it before controlled discharge or further use. Solid waste is separated by type, while recyclable packaging materials can be recovered and process losses are managed through controlled waste handling systems. After inspection, individual portions are grouped into larger packs, coded for traceability, and placed into cases for storage and distribution. Finished cases are palletized, recorded in inventory, and stored under the conditions required by the specific product and packaging system. From the warehouse, finished gelatin moves through regional distribution networks by road, eventually reaching supermarkets, food service operations, and other points of sale. At industrial scale, cost is influenced by collagen yield, ingredient prices, energy, water, labor, packaging, quality control, equipment utilization, and distribution. The next generation of gelatin plants is moving toward smarter sensors, automated visual inspection, predictive maintenance, tighter process control, water recovery, and more efficient energy use. From collagen-rich raw materials to extraction, purification, drying, formulation, filling, inspection, and distribution, every colorful spoonful is the result of controlled industrial engineering. If you enjoyed seeing how this hidden process works, subscribe for more factory documentaries.